Okay, so let's jump into this video and talk about our MAF compensation feature in our ECM Link software. So MAF compensation is going to allow us to correct for any kind of differences in our air mass reporting. So we have our OEM, let's say our mass airflow sensor installed on our intake, and we install a different intake that can flow a different amount of air into the engine. We need to correct for that. So this is going to be a two-dimensional table. It's going to allow us to make adjustments based on different frequency ranges of the mass airflow sensor. Now, if we've installed a different mass airflow sensor, such as a GM, we're able to recharacterize the MAF curve and do some fine tuning with our MAF compensation table. I'm going to go over both situations in this video so it's very clear how to do your adjustments and what you need to look for. So without further wait, let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at our MAF compensation in our ECM Link software. The MAF compensation is going to allow us to have further fine resolution and control over the reported air mass coming into our engine. So we may have a different mass airflow sensor fitted to our vehicle. We're able to select here from the drop down some common options, stock, EVO 8, or a GM mass airflow sensor, depending on what we're using. And we have the ability using this table here to make small adjustments to the reported air mass. So if we're finding it's going to be rich or it's going to be lean as we're doing our driving, this is going to be what we do to correct it. So we're either tell the ECU that we're reporting more or less air mass depending on what kind of frequency we're going to be operating at. We're going to get into the details of this table a little bit later in this video so we understand how to work with this. We're going to have two calibration methods, either a manual method or an automated method, and I'll go over that so it makes a pretty clear sense of what you need to do and adjust. But right now, before we go into this, we need to understand how the closed loop operation is going to be functioning in our ECU. So this is going to be playing a role in how we actually go and tune the idle and part throttle areas of operation for the mass airflow sensor curve, and that's going to be a large part or the large area of what we have here to work with. So this is going to be important to get our drivability nailed down. So the first and foremost thing here with the closed loop operation, we're going to find idle and part throttle are going to be in closed loop. When we go into full throttle, it'll go into open loop. So it's going to have a threshold where it goes from closed to open, which we have the ability to go in and actually change that threshold. We'll talk about here in a few minutes how that's going to be correlating and what we need to do to make sure that's set up correctly so that we're able to do our MAF compensation tuning properly. We'll find that we have a short-term fuel trim and a long-term fuel trim. Both of these fuel trims are going to be applying in closed loop. So what we'll have is a primary O2 sensor. That's going to be our front O2 sensor and the O2 sensor housing. That is going to be a narrow band sensor. The narrow band sensor is going to be a 0 to 1 volt scale, and around the half volt point, that's going to be the output that's going to be equivalent of 14.7 to 1. So when it's reporting back the air fuel to the ECU, it's going to be taking a look, the ECU is going to be taking a look at that voltage range. If it sees a half volt, it knows that it's at 14.7 to 1. If it's going to be higher or lower than that value in voltage, it's either going to be leaner or richer. So we're going to have to start to make some adjustments, and that's what the short and long-term fuel trims are going to be doing. It's going to compare the reading from the O2 sensor to the target air fuel we want to run at. In this case, it would be 14.7 to 1 or stoichiometric. So in the situation where we're going to have a difference, the short-term fuel trim would make the instantaneous or first correction. So whether we're going to be at idle or part throttle, the short-term trim is going to always be moving around. You'll find that's going to have, we can log it and take a look. We actually have a data log here. We're going to be reviewing that here in just a second. Now the long-term fuel trim is going to be constantly monitoring the short-term fuel trim. And as we drive around, it's going to be populating learned data. So if the short-term trim is constantly taking out, let's say 5%, the long-term trim will absorb that and then turn the short-term trim back to 0. So the short term is going to be the instantaneous correction. The long term is going to be just a more long term of what the short term is doing. And we'll find we have 3 different zones for the long term fuel trim. We're going to have a low, a mid, and a high. So depending on where we're operating at, typically idle, very, very light throttle is going to be low. A little bit more throttle is going to be the mid. And then the high is going to be right before we transition over into open loop at the very high throttle angles or higher load. Let's take a look at a data log so we can kind of make sense of this and how this is going to work in my data log. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.